With the growing industry of extended reality, we can only expect that various forms of XR soon become an integral part of urban planning and design process. In this research, I tried to answer a broad question of how to implement virtual reality throughout the urban design process. With appropriate plugins and apps, modeling applications such as SketchUp and City Engine, and mapping applications such as ArcGIS can be used to recreate a space in virtual reality. In this project, a number of VR applications have been evaluated to test their use in the urban design process from the ideation phase to public communication and final presentation. A new workflow of design process has been conceptualized to use a selected number of VR apps at different stages of planning and design. The proposed workflow has been applied in the urban design project of a commercial corridor in the city of Gilroy, California, as part of an academic urban design studio. The main focus of the research was to use the VR apps and devices that are accessible and easy to use. I have to clarify that the other forms of extended reality, such as augmented reality or mixed reality, was not in the scope of this research. Our design studios typically have a community engagement phase, which we were not able to do due to the recent pandemic and the fact that we had an online studio. We will repeat the proposed workflow in our next urban design studio in spring 2022 with the community engagement component. In the previous years, we had a very simple workflow of applications in the three categories of geospatial modeling and communication, starting with ArcGIS programs for gathering data and site analysis, and AutoCAD and SketchUp for 2D and 3D modeling, and finally Adobe programs to produce final materials. As the first phase of our project, we identified a relatively long list of emerging apps in all application categories. In particular, the recent developments in the area of 3D GIS with programs such as Urban and City Engine has opened new possibilities, not only for the design development, but also scenario planning and design assessments based on indicators or metrics. The biggest opportunity was the compatibility of geospatial programs with a number of VR apps. It was clear from the beginning it's not practical to work with all of these apps, and a simpler workflow has to be conceptualized. Few factors were involved in our decision to identify the appropriate VR apps. The most important ones were their ease of use, their cost, their compatibility with the other softwares, and their compatibility with the common headsets in the market, especially Oculus Quest 2, which is a portable and relatively cheap device. Here you can see the final workflow of the programs that we used in our studio. The size of the squares indicates the relative importance or the amount of time we spend on each program. Web-based programs such as ArcGIS Online, Urban, and Story Maps made online collaboration possible. We narrowed down VR apps to 3 programs at 3 stages of design. The following video explains how we incorporated these apps in the design process.
This video details the workflow process of integrating virtual reality into 3 stages of the urban design process: organization, ideation, and presentation. This workflow is applied in the urban design project of a commercial corridor in the city of Gilroy, California, as part of an urban design studio at Cal Poly. A VR workspace called Spatial was tested as a collaboration tool for remote partners. Advantages that come with working in VR include being able to bring in desktop screens into a virtual office and creating an immersive workspace that focuses both on the people and the content. SketchUp models can be created, viewed, and edited collaboratively in VR using the VR Sketch extension. The biggest advantages are getting an immersive experience at the early stages of design and having multiple people work in the same file at once. The team utilized a combination of different programs to create the virtual reality experience using 3D GIS files. First, ArcGIS Urban. ArcGIS Urban is a web-based program that produces interactive 3D environments for creating land use and zoning plans. Students envisioned 4 different scenarios for Gilroy's commercial corridor, each with a specific theme and zoning regulations. What resulted was a 3D representation of each scenario while also quantifying the added population, jobs, homes, and environmental effects of each scenario. The 3D urban models were imported to ArcGIS City Engine, a procedurally modeling software to add street network design. The procedural modeling is based on rule packages that allow for efficient modeling of large and complex environments. City Engine was used to generate streetscape elements for all scenarios. To create the final VR product, the City Engine model must be brought to Unreal Engine. Unreal Engine is used for further edits, such as adding teleportation locations. The final product is the immersive experience of all 4 scenarios that can be used in the public engagement process and the final presentation.
In the next few slides, I'm going to summarize some of the main benefits that we found in the application of VR at different stages of design. At the end of my presentation, I'm going to summarize some of the technical, psychological, and ethical concerns that we noticed in our experiment. First, VR workspace such as spatial or vSpatial can have advantages over typical virtual meeting platforms such as Zoom. The immersive environment can reduce the distraction to increase work productivity and also the possibility of multi-monitor sharing or even bringing a 3D model into the VR workspace that can facilitate the communication. The biggest advantage of viewing and editing conceptual models in VR through applications such as vSketch is to provide a human scale model in the design process. The cloud-based program, the possibility of editing models with numerous users in real time, facilitates peers collaborations. In the presentation phase, the combination of ArcGIS Urban, City Engine, and Unreal Engine provides an interactive medium on which users can have immersive experience on multiple design scenarios in real time at their own choice. Plus, the generative nature of modeling allows speeding up the quality and comprehensiveness of visual planning. Finally, here you can see a list of technical, psychological, and ethical concerns that we notice at each stage. The biggest technical concern, I believe, is the efficiency consideration. The VR apps are more user-friendly than before, but still they require training and the adaptation process can take time. In case of vSketch, for example, it may never get as simple as using the desktop version of SketchUp. On the psychological concerns, user discomfort and motion sickness is a common issue discussed in the literature, and some of our students experience similar difficulties. But also we face the issue of user acceptance and trust even among our students, since the use of VR has not been normalized yet in the planning process. For the ethical concerns, the issue of accessibility was clear. The user's previous VR knowledge and experience and access to hardware makes them ahead of others in the use of technology. Also, data privacy concern was real since we had to log into our Facebook accounts to use Oculus Quest 2 headsets. Finally, potential manipulation of information. For example, in our 3D model, the users will see the street design in more details than the buildings, and that can potentially create a flawed perception for the viewers. As I mentioned before, we couldn't test our workflow with the community engagement component, but we are planning to do so in our Spring Studio, and in the future, I would like to explore other forms of extended reality in the urban design process. Thank you all for listening.